We present SF3D stable fast 3D mesh reconstruction with UV unwrapping and illumination disentanglement. We noticed several issues with existing fast feed-forward reconstruction methods. Existing methods only learn the radiance of the input image. This bakes in the illumination, making the asset difficult to relight. Our method instead learns the illumination of the scene and can hence remove it from the albedo color. Additionally, we found that the commonly used vertex colors do not produce sharp textures and UV unwrapping is slow. We propose a fast UV unwrapping step which enables UV unwrapping and texturing in approximately 100 milliseconds. This allows our method to produce sharp textures with a low poly geometry. Most previous methods rely on marching cubes for the mesh extraction. Even with a high resolution, this can leave obvious staircase artifacts. Instead, we train our model to be mesh-aware and learn displacements and shading normals to produce smooth assets. Additionally, most methods do not predict material parameters. This creates unrealistic renderings of assets without proper reflective properties. We predict roughness and metallic parameters per object, which enhances the rendering quality substantially. Our method is based on Large Reconstruction Models, LRM. The input image is first passed through a Dino V2 encoder to get our image tokens. We train a large transformer conditioned on these image tokens and camera tokens to predict a triplane volumetric representation. However, instead of relying on differentiable volumetric rendering, we use a differentiable mesh renderer and mesh representation. We extract the mesh from the density field. We further add predicted vertex offsets to produce a smoother and more accurate mesh. We then extract the albedo color and tangent space normal for a visually even smoother surface. We also take the input image and pass it through a network to predict additional material parameters. During training, we also predict the illumination as a set of spherical Gaussians. Here, we extract them from the triplanes, as they contain reasoning about 3D. We differentiably render the final image given all components. With these additions, our method is capable of producing assets with high fidelity in under a second. Here, we show a real-time demo. We compare our method with several recent fast feed-forward reconstruction methods. Our method creates more accurate shapes with smoother surfaces and plausible reflective properties. The impact of the input illumination is also severely reduced. When comparing our method on reconstruction quality versus inference time, SF3D outperforms all other state-of-the-art methods. Thanks for watching.